Okay, well, for people watching this live stream, this is a continuation of a design meeting about SPARQL, graph databases, and entity stores. So we were just talking about the relationship between SPARQL and graph databases and so on. And I think, just to be clear, I mean, the number one use of this for our own purposes is to provide another backend for entity store. Is that correct?
Yes, that's one use case.
Well, okay, so to my knowledge, there are two known use cases. Well, maybe three. One use case is alternative backing for entity store. Another use case is connecting to existing SPARQL endpoints. Is that correct?
Connecting sounds like a lot of setup. It's really directly querying them.
Okay. Querying. Okay. And a final one is basically defining a system for graph pattern matching. Is that right? I mean,
I would see it the other way around.
Okay.
Like if we would have a full-fledged graph pattern matching, then that would go into here. But one could, of course, see it initially. This one would be an initial graph pattern matcher.
Yes. Well, hold on 1 second. Let me just ask a question there. And did Roger end up joining us?
No, he preferred to be on call, but I can get him.
Could you ask him to actually join us for a minute?
Yes.
Thanks. Does anybody know where I'm storing this stuff? Was it in
Graph Store?
I don't seem to have a thing called Graph Store.
I thought that's what you said yesterday.
Oh, I have a thing called SPARQL here.
Okay.
Okay. All right. So my question for this is, if we have a big graph and we want to do matching on it, I mean, is the implementation that we have actually efficient for doing various kinds of graph matching? And, what's the right way to think about that? We have a big graph and it's an in-memory graph that's working using our standard graph mechanisms. Should we be using this as the matching system, or is that silly?
So the graphs are completely different. A graph that is unlabeled and these triple graphs or RDF graphs.
I understand that. But I mean, we need to go to a place where our existing graph objects can deal with labeling of the same kind that we find in these triple graphs, I would think.
One comment here, Stephen, is that if you are talking about efficiency, then most likely dedicated database engines for graph databases have vastly more efficient implementations, particularly for these types of graphs, than we could ever hope to get.
No, I know. That's why I'm asking. Mm-hmm. Okay, but let's look at this question. I mean, so let's talk about alternative backings for entity stores, okay? So, previously we have talked about using our relational database capabilities as an alternative backing for data sets. What is the state of that? Leonid, maybe you can say something about that.
Yes, I actually think that while we didn't pursue this direction very far, it is reasonably much easier to do than what we are doing now with the entities. Because what we have now is an intermediate representation for the database queries to which we compile entities. And even like, almost a year ago, I suggested that we could also compile dataset language to the same intermediate representation. And this is still true. So whenever we want to support dataset backed, represent the relational database as a bunch of datasets, I think it won't be that much work to compile dataset language to that intermediate representation and add. The only thing we will need to add really will be a relational lookup hopping through the tables as a single operation that would extend the dataset language that is currently lacking.
Okay, but so let me just understand something. So let's say I have a random data set. Let me pick up a random data set from somewhere.
Yeah.
Okay, let me go. Let's say I go to the data repository. I pick up a. Oh wow, that's rather unimpressive. No, why do we have a category called manufacturing if we don't have anything underneath it? Who knows? Okay, so let's say I pick something like this up. Okay, so right now, this is going to be, what is this? This is the same thing I was seeing yesterday. Does anybody know what this is?
Actually, I have heard many people talking about it, so it seems to be a pretty widespread issue.
But I was told yesterday that it was fixed.
Well, maybe it is. Maybe this version that I'm running here is the wrong version. Let's see. If I quit this, then I have to. Let's quit out of that. Let's try this version, which should be a current 11.3. Okay, let's try this again. I don't know why it's flashing that thing. It's not supposed to do that. Okay, fine. So this is a random data set, okay, currently in memory. So my question is, what do we think this is going to look like in a, if it was backed by a database?
Okay, so first of all, one big distinction between these use cases is what are the types of the columns in this data set. As we can see here, some of the types are things like time series, which means that, I mean, right now, what we can do rather easily is to support data sets which would be represented by columns of the types that databases can consume immediately.
Mm-hmm.
But pretty
still, but that was the whole point of the serialization, binary serialize.
Yeah, sure, we can do that. And once we hook this up, we could also serialize time series as a binary thing that we'll just store in a database. The only problem with this approach is that you can't then use database capabilities to actually query that time series by the means of databases, you know.
Right, but then you have to pull it out and do the same standard data set query.
Yes, but the other option might be, and at some point we may reach that option, that it will be possible to represent these objects in a way that is more, that would allow databases to do certain queries using their own
Look,
machine.
I would think that this is something with the compiler, for example, that we get closer to being able to think about that. It seems a complicated project.
I think, but
yeah.
this will repeat for any object that's a little bit more complicated.
Yes.
One thing I want to mention is that right now, in the process of working with the types, because we need now to work out the database types for our purposes, we are also considering dealing with composite types that would eventually open the door to this kind of things. And it won't be very easy, but it will already now be in our framework the potential capability to extend that to actually treat those objects. So in particular, the single data set containing, for instance, a column of time series might be translated later on into more than one table, so that basically you have a foreign key to from.
Right. I get it. But that's lovely. But I mean, for the time being, these are just blobs of binary serialized.
Yeah, for the time. Yeah, for the time.
I mean, like images are not going to, databases as such are not going to deal with images.
Actually, they can, because you can. Some of the databases natively support arrays.
Yeah, but that's not an image. I mean, it's like whatever. I mean, but
yeah.
Okay. What I'm trying to understand is, you know, this is an example. So what would it look like if this was this will be backed by a database which is sitting either locally or remotely.
Yes.
Is that the idea?
You mean relational database?
Yes.
Yeah, sure.
And similarly, in the SPARQL case, an entity store could be backed, presumably. I mean, I don't understand. We can have a local SPARQL thing running with our own SPARQL endpoint server. Is that correct, Tony?
Yes.
And is that a lightweight thing? Or go ahead.
Yeah, there's actually an example in the agenda that shows that. So there's one line, if you scroll a little bit down, SPARQL endpoint update. Yeah, this shows how you start the server. This is just one command line, and then you can start reading and writing to that SPARQL endpoint, which is running locally.
Okay. And the idea for this would be something similar, right? That you start a local database server. Is that right? If you wanted to, so I'm trying to understand. If I could potentially have, I mean, in the case where I'm loading something from the data repository, for instance, right? This data repository thing caches locally in the file system, right? One could imagine that instead or as well as caching the serialized data locally in the time, I mean, I think it's caching an MX file locally in the file system. Does anybody know? Who did that infrastructure? Was that Nick? Or was it Bob? I think it was Bob Sandheinrich. Was it?
I would think Bob.
Can somebody see if we can find Bob and ask him about this, Eric? Okay, so what I'm trying to understand is what this would look like, what the complete workflow for the user would look like. Okay, so for example, they have a bunch of data. They say, okay, I want this stored. It either comes from the data repository as a database, or they decide to store it as a database, or a graph database, or a SPARQL thing. And then it would sit in the local object store, presumably, or it could be a cloud-based thing where they are simply referring to some cloud endpoint. Am I right?
I'll come back in just in a minute. I need to reboot. I'll be.
Okay. Okay. Am I right, guys? Tony, Michael, Leonid?
I think so, but I'm not expert in this corners.
Yeah, looks like basically whatever specific storage you get, you end up with an entity store which will have a handle, and that handle can be something, local or remote, but it will be the system's task to know how to work with that handle.
Right. Well, I think the resource system.
Hi, it's Bob.
Hi. We are talking about, well, we're originally talking about SPARQL endpoints and graph stores. Okay. But what we're now talking about is in the resource system, I load a resource object, and if I'm not mistaken, it's cached in the local object store. Is that correct?
That's right.
Is it cached as an MX file in the local object store?
For data resources, yes. Neural net is WLNet, and so on. Different resource types have different formats.
Okay. All right. So if we were to cache a database there, I'm still a little confused by how this would work. So imagine that this, I see. So what could happen is that something, just like in the data repository, things can be entity stores or they can be data sets. So they could also be in principal databases. Am I right so far, Leonid?
Well, for a database, you basically need a database server unless it's an SQLite file. And so you will have to actually create the database. So if you don't really expose that directly here, because that database server
Well, there are two different possibilities. One is that from the data repository, you are going to load up a clone of a database locally. And the other possibility is that you're querying the single copy of the database somewhere in the cloud. Is that right?
Yeah, so, I mean, if it's a relational database, then I can imagine you could have a dump as an SQL dump, and that dump you could store in the repository so that people could download that and use that. But that's probably not what you meant. You meant something like a handle that is directly queryable, right?
No, there are two cases. One is that you clone it locally, and the other is, okay, what is the most common case of relational databases? The most common case will be somebody has an existing database that's been fed by some existing system, and we are merely querying it, right? Now,
yeah, but you know, if someone wants to give it away for querying, then either they have to expose the database server to anyone, or
no, for the data repository, yes. For the public data repository, yes. But in a typical setting, like at our company, we've got plenty of databases which have a certain authentication, and then you can get to them, and then you can read something from the bugs database or whatever else it is, right?
Yeah, that's right.
So in a typical corporate setting, what one would expect is that one would have, what one could have is some nice curated list of relevant databases. That's sort of what we should have at our company, that if you have the appropriate authentication, you can connect to in the language. Am I making sense?
Yeah. So basically, we have some kind of, connection objects, which would be, one could potentially have some handles where one would just have to provide extra authentication information to make them turn them into connection.
What would be a nice way to do that? So if we had a database collection or something, let's say that in our private cloud, we had a thing that was like the data repository, but was essentially a database collection, database connections collection. Then for each of those databases, we'd have a nice page which explains how you get to, what it does, blah, blah, blah. It's effectively documentation for the database. And then what we would expect on that page is that there will be a connection object, and you copy paste that connection object.
And you'll need another thing like authentication object or something like that. And when you combine them together, there will be a way to automatically create connection from that, leave connection.
Yes, I understand. But I'm talking about what the actual workflow of people using this would be. And one thing is that, somebody secretly sends you an email that gives you information about how to connect to that database. The other possibility is that we have a more organized way of presenting on what amount to, repository pages, connection information for databases. And that
this sounds similar. We've talked about having service connection repository.
Yeah, that's a good point.
And it sounds more similar to that than data, unless you're taking snapshots.
No, I agree with you. Right. What have we thought through? How far have we thought through the service connection repository?
We haven't talked about designing web pages at all, if that's what you're asking.
Okay. But yes, you're right. It's very similar to that. So fine. And presumably now, so let me ask this question. In the general world at large, there are a certain number of SPARQL endpoints that are exposed for general querying. There are not, I suspect, maybe I'm misthinking about it, but people don't generally expose database endpoints for general querying, except insofar as websites are, have database backing, right? But nobody is exposing something which can be connected to by our database connector live over HTTP or something. Leonard, am I confusing something?
Well, maybe there are a few exceptions or services which do that, but normally it goes through the layer of representational layer. So usually people don't expose directly things that you can query via SQL. One notable exception is, for instance, the Stack Exchange Data Explorer, where we are actually going to use it as a test bed for our system. where basically they expose pretty much directly the interface where you can write SQL query. They give you the schema of the whole Stack Exchange database. Obviously, that is a clone. And you can query the entire thing with all the answers, questions, etc. using SQL. But I don't know how direct is that.
But
Probably
that's a rare case, I suspect. And
yeah, that's a rare case.
Even in the case of SPARQL, it's a slightly more published, endpoints. But even there, we're not seeing very many SPARQL endpoints that are out there in public.
Yeah, and I suspect that even in cases where people expose things, in many cases they might actually put your query through certain additional steps to enable.
Fine. But okay. So okay. But back to what we're talking about here. So another case. So the case is for databases is there is a database. It is typically a local corporate thing. It has you're then for us, you're doing this database connect function, if I'm not mistaken. Is that what we're calling it?
Yeah, but it also is often handled automatically for you by the backend. So unless you have a special need to actually do the connect yourself,
well, then what does it look like? How do you reference the database then?
You create the object that is called database connection, and then
how do you create that?
Well, you need for that the information, basically the connection string, or the server, the name of the database, and all those parts that
which is typically some kind of URI type thing.
Yes, it's some kind of URI type thing, and the only thing is normally you don't provide authentication straight in there, although you can, and so yeah.
Okay, but we have an authentication option which presumably can use our authentication structures like username and password or other kinds of things. Is that right? Yeah,
well, we didn't hook this up yet, but potentially, sure.
Well, we should do that. I mean, do databases use things like OAuth, or is that a different technology stack?
Say again, sorry?
Do they use things like OAuth, or do they use username and password?
No, I don't think they use that. It's just the usual authentication through the... Eventually, it still becomes a URL string. So
it's username and password, basically.
Yes.
Okay. So but by the way, you should hook up the authentication function, and we've got all these nice services like authentication dialog, which requests username and password, et cetera, et cetera, et cetera.
Yeah, sure.
Okay, but I'm still walking through what we were actually doing with this. So then, let's see. So
then I would say you create entity store from it.
From which?
From your connection information, from your connection object. And then that entity store provides you an interface to query your database.
Yes. Okay. But now what you're saying is the SPARQL thing is an alternative way of representing an entity store. Is that right? Tony?
Not directly, but you can or will be able to configure an entity store to consume that RDF data and present it as entities. There are some choices that can be made, and that has to be configurable.
Well, but wait a second. I mean, one of the things we talked about as a use case for this was to provide a backing for entity stores.
Yes, exactly.
Okay.
And this backing, there is no unique choice. So which subset of all the resources in the RDF graph are actually considered entities, which ones are properties?
I see. But okay, but the raw use of a graph store is something, I mean, walk me through again. So again, with respect to databases, the 98% use case is going to be people have an existing database, they're accessing it, they want to do things with the data in it. That's what is supported by, doing these connection things. And then the thing will show up in our system as an entity store. And we've built all of these things like entity function and so on that allow you to manipulate the entity store. Is that correct?
That's one possibility.
Well, but Leonid, I mean, that's what you've been building, right?
Yes. So in the context of relational databases, that's the workflow.
Right. So, okay. So then for the graph databases, an alternative, I mean, there are many fewer graph databases out in the wild, you know, but one possibility is you have a graph database out in the wild and you want to use entity store technology to query that graph database. Is that a use case here?
Yes, that's a possibility.
And in order to have things not go bonkers, it better be the case that the entity store queries that can be made through Leonid's, you know, the database integration system are the same set of queries, or those represent a subset, or at least not a, okay, how does the set of queries that can reasonably be made through the thing that is built on top of the relational database, you know, ORM system, et cetera, how do those queries relate to the queries which are natural to make on a graph database?
Well, if you ask me, then my very, very small understanding of RDF databases is that one would be able to implement all those primitives that we have introduced in the context of relational databases also for the graph databases as well.
Tony?
And there will be other things that are only available for graphs and which don't have a very direct analogs for relationals.
And there's the other way around. Are there things which can be done with relational that are essentially impossible with the graph case? I don't think so. I would think that the graph case, that the relational case is a subset of the graph case. Am I right?
Yeah, in a sense. On the other hand, it has been shown that all the graph, like I think SPARQL, could be compiled down to SQL in a sense. So
yes, so there's a translation in both directions. So because each triple graph, you can just store it as one large table. So in principle, there's always a translation.
Yes, I understand that. But I mean, in practice for us, when we have things like entity function and all these kinds of things, do we imagine, Tony, that your system will support those? Or
yes, so I have already started experimenting with that, so that should work. So all the new entity functions that we are introducing for the relational backend should work with RDF backends.
That's cool. That's really cool. But now, what additional functions could you support with the graph backend that are not reasonable to support with a relational backend? I mean, a lot of these you know, paths of related entities surely are hard to support.
Yeah, and actually, Stephen, there is one very important thing here is that for all relation queries, we really need to know the schema exactly as a rigid thing. And because our SPARQL endpoints don't necessitate the schema, then obviously those queries which, you know, are formulated in terms of not referring to the schema, we'll have hard time doing that in a relational world just because we.
Yeah, I get it. Know. Okay, so my question then is, what? Okay, so if we've got an entity store, like we've got various random entity stores in the data repository, like the crazy one, like Nathan's crazy one with amniotes and things, and you know, properties of animals or something. That particular one, for example, seems naturally like a relational, something that could be stored in a relational database. So do we have examples of things in the data repository which are not conveniently stored in a relational database, but which are naturally stored in a SPARQL type world as an RDF triple store or something?
I'm not sure there's one person here who can answer that.
I think it's a little bit less consistent. I think the things that we put in the data repository are mostly the ones that fit.
Okay, fair enough. Okay, but so walk me through, if we were going to go out in the world and find things that would naturally be represented in a sparkly way, what would we find? I mean, for example, our own surf is an example. Semantic relations framework is an example of something that.
Yeah, what are some examples of use right now for SPARQL for these RDFs?
Well, what we've got here is Tony wrote down this list of public SPARQL endpoints like Wikidata, like this European art thing, like music brains. I mean, honestly,
very short list so far.
it's a short list, and I know, we've been tracking this for years. It's always been a short list. Now, there was a big excitement about SPARQL in US government circles, maybe a decade ago or something. And I don't know how much actually got built out from that.
So when I checked last year, I went to some random German library website and downloaded their catalog of all books as a turtle file. That was a 1 gigabyte file of the whole catalog. And the idea is that we will be able to process such data. At that point, the importer was too slow to actually finish, but we are getting close to being able to import such big files.
Okay, so you import a 1 gigabyte turtle, whatever that might be. I mean, that's a heck of a lot of books, right? 1 gigabyte. I mean, a typical library a big library might have 5 million books, and each book has probably a page worth of data at most. So I'm not understanding how you get to a gigabyte or unless they have like cover images and things.
It's a lot of relations, but.
Yeah, what are in those?
But a million books.
I mean, how do you represent it? What does that triple? What is it?
Like the books and the authors and the birth dates and all the typical bibliographical information. Yeah.
Right, but this will be naturally.
What's in the triple? Because there's a triple. There's three things.
The author of the book was X. So author, book, and X. 3 things.
Oh.
Well, in particular, actually, the connection would be usually author.
Has written.
Yes, and then book. And the has written is the edge, and the author and the book are nodes.
I see.
Now, whereas in a relational setup, that would be simply, in the in the list of authors, in the list of books, a property would be the author, and that's a particular thing, and that would then be a key potentially into a foreign key into another database. Am I right?
Yes, and if there is a multiple to multiple relations, then there will be intermediate table, which will essentially be that edge, which is here represented by written by. And in relational setting, if you have many to many, that written by edge would basically correspond to an intermediate table.
Okay.
It's just a matter point. I still think that for things that are mostly rectangular in nature, so you go through all these species, you measure their mass, their running speed, this will not show off any of its power. But if you have anything that's kind of more real and organic, like the sciences itself, like the theorems of math, or even the network of authors, there is where this non-trivial network structure comes into play.
Okay, but so you're saying, let's say there's a bunch of nodes that represent people.
Yeah, like what's your relation to Newton? What's the shortest path?
Yeah, right. So
there is another thing here as well, that whoever makes a structured relational database out of the data, they make certain choices which reflect how they choose the schema. And in this SPARQL world, you don't have to make those choices.
No, I understand. But let's talk about the relation now to graphs. So, for example, a social network, has a bunch of nodes that represent people, but the edges of the social network are purely some kind of friend connection or link in LinkedIn or whatever else it is, right? So there's kind of only one type of edge, if I'm not mistaken.
They can model all kinds of things, but what exactly that is, you say when you build the graph. When you
no, I realize that. The point is that the sweet spot of the RDF triple business is there isn't just one type of edge. There are lots of types of edges. And, in other words, the claim that I'm making is most of the stuff we do with graphs and networks involves effectively one type of relation, like is a friend of or is linked to.
Stephen, but it's only on the surface. Then you can see that there are different ways of how people are linked to. Could
Well, I
be
know that, but-
professional, you know, could be personal, could be something else.
I'm aware, but the fact is, in the way that we are currently, our graph theory functions, okay, mostly do not allow that possibility, right? Our graph theory functions are built to analyze mostly graphs where there's one type of edge. Is that a fair statement, Roger?
Well, that's an interpretation of it. You know, effectively, it's a binary relation.
Yes.
You know, and how you choose to what that binary relation models. There are many ways in which you take a n-ary relation into binary relations.
Sure, but my point, Roger, is that binary relation, yeah, it is a binary relation. That is, the edge is merely a relator of two things.
Right. But for instance, you can, one way to take, let's say that you have a ternary relation.
Yeah.
You know, or you have,
sure, you have an intermediate node or something.
But you can take the union of two binary relations. So then the edge means that or that or that.
Fine, I get it. But my point is, what the set of functions, the 100 functions or something that we have for graph theory, are mostly dealing with. I mean, the issue here that's coming up is if we're extending our, on the one hand, there's our pattern language. On the other hand, there's the graph theory stuff.
Yes.
And what's happening here is this is somewhere in between those two. So we're talking about things like graph cases, but we could imagine a graph cases that is merely for our binary relation style graphs. Right? That is, there could be a graph cases where you say, where things are connected, like the nodes, the people, there could be a person who is can one connect, how is purely by the friend relation, how is this person who was a Boy Scout connected to this person who climbed Mount Everest or something?
Yeah.
Where,
I think that these very data-oriented sort of uses of relations, like the n-ary relations of relational databases, and they're still binary. It's just a big soup of binary relations, it seems to me, the triple.
Well, fair enough. Yeah. But okay, but look, what I'm trying to get to is, what is the sweet spot use case for the triple store thing, and how does it relate to, on the one hand, our graph stuff, on the other hand, our database stuff and entity store stuff? Okay, because otherwise we don't know where. I mean, we could try to build out something.
Well, I think that one could try to enumerate cases.
Well, that's what I was starting to do earlier in this meeting. Yeah, but I mean, the triple store case seems to me a lot of, look, I can imagine all kinds of funky, law enforcement style, or, financial, how is this connected? How is an earthquake happening here going to be related to, the price of an iPhone, a month later, because this is connected to that, is connected to that. And the relation might be, there is a mine that is in this particular place where the earthquake happened, and that mine is a supplier of stuff to this place, and that supplier connects that stuff that is, I don't know, tantalum is used in some weird rare earth magnet that's used in this, that's used in that, et cetera, et cetera, et cetera. And somehow you've got to
so I can imagine that there are, so it seems like this triple source is like a sparse way to represent all of those possible relations, because it literally.
That sounds right. Yeah.
And there's the query language can probably go a certain ways to use those relations.
Well, the query language has, the query language, Roger, has graph matching. So, for example, this Boy Scout and Mount Everest example. Well, no, let's take this. You can say, how is this connected to that? What is the path that connects this to that? And you can say, Tony, correct me if I'm wrong. You can give some pattern features of that path, and say, give me a path that has these types of edges in it, or something like that. Is that right?
Yes, it's basically a regular expression language on the properties. or the
But see,
predicates.
I can see how we can convert either way. I see how we can sort of extract a graph of something of interest that we then have other kinds of analysis tools that are available. And I can see how we can take a graph and inject it as a triple store.
Yes, I agree. But I mean, the point about the graph is our generic graphs have only one type of edge. Is that a fair statement, Roger? I mean, we don't have a convenient way, and we're talking about introducing such a thing. And that's one reason I wanted you or Charles here, is that, you know, we've been talking about the possibility of having a, what did we call it? Some kind of, what were we calling it yesterday? Graph edge or something. And we had, you know, a potential, I mean, that is something which appearance-wise will be A, and then, you know, our arrow B, and then this edge will be annotated with something. Am I making sense? So, for instance,
But aren't there graph edge labels already?
I mean, but is it purely visualization? Because, you know, to get all the operations to work properly with that is massive.
Oops, that is funny. What just happened there?
You know, this is the big problem. Isn't to just, you know, I mean, visualization is a problem, but the big problem is to define meaning for these hundreds of operations.
No, I realize that. So the possibility, but that's what the SPARQL business is doing. That is, it is dealing with graphs that have labeled edges, if I'm not mistaken. And there's certain operations that, so for example, let's imagine you were doing graph isomorphism with labeled edges. That's a whole different world from graph isomorphism without labeled edges.
Yeah.
And, you know, so Tony, you've enumerated certain operations that are, you know, that are ones that are conveniently thought about in terms of these labeled graphs. Is that right? So
Yes.
Do you have a list of those someplace in here?
Yes. If you go a little bit down on about the middle on, yes.
I mean, but there's a question whether they're still.
Further down.
I mean, it's, you know, I would say that they're probably not recognized as graphs anymore.
Sorry, further up.
What's this? Where are we going here?
Further up.
Further up.
So it's still in the section RDF.
Okay, but this seems relevant here.
These are the SPARQL patterns. So there may be 10 different pattern types that SPARQL supports.
Right.
Yeah.
So I mean, these are.
So there's a relation between SPARQL select or SPARQL ask, the SPARQL pattern matcher, and a potential graph cases function. And when I looked into it, I understood there's some intersection of functionality that they have, but there are certain things in graph cases that can't be easily or maybe not at all be done in SPARQL, and vice versa. For instance, the concept of subqueries in SPARQL wouldn't be possible to fit that into something like graph cases. Unless we introduce some completely new pattern constructs. For instance, things that allow processing of the pattern on the left-hand side of the rule.
Yes.
So, I mean, I've dealt a lot with ternary relations because they effectively model finite automata, whether those are deterministic or non-deterministic. You know,
because on the edges there's a symbol that is, you know,
exactly
the output symbol.
You know, but they're not graphs. I mean, you can sort of, you know, they're just not graphs.
What the heck are they then?
Well,
I mean, they're not hypergraphs either.
You know, we have tons of literatures on graphs, and they're certainly not acknowledged as graphs.
Right.
Yeah. So the most mathematical description we have come up with so far is they are ordered directed hypergraphs where the edge length is always 3. Yeah. Ordered directed hypergraphs.
Yeah. Okay. Where there are 3. What's that?
I think that's the correct technical description.
Right.
It's a different thing, you know. I mean, but it's a good thing. But it's better to recognize that they're related, but they are a different thing, and don't try to force it. It's like saying that, yeah, we have tensors, but they're really matrices. We're going to treat them all as matrices. you know, and there are some big bunch of areas of science that do just that.
Yeah.
You know?
Okay. But so, okay, edge labeled graphs, aka triple stores, is one possible construct that we could have where we could do certain graph theoretic operations on it. I mean, like connectedness or something. That's a perfectly reasonable concept for that. See, the main issue is in typical graph theory stuff that we do, we're gulping the whole graph down in one go and doing something to it. In the typical way that you're using SPARQL, you're absolutely not doing that. You're picking away at some particular, path in the graph or something like that.
Sure.
And it's the same sense in which, in one of our data sets, you've got the whole thing there versus something where there's a remote database and you're picking away at some piece of it. That's not a great analogy, but yeah. I mean, similarly with the entity store, there's a question of whether you're picking away at some particular entity and property or whether you are gulping the whole entity store and analyzing it. All right, so where are we going with this? So I'm trying to understand, there are, certain cases in which you've got, just a bunch of triples. I mean, how should we think about this? I mean, we've got things like our existing, semantic relations framework, which is pretty organized into entity property value type setups. It's not a free floating collection of random triples. Right. And, in the things that, I mean, I can see situations in which it's very useful to know. I mean, look, if it's how is this connected to that? Okay, so again, okay, let's say we're trying to analyze, I don't know, what effect, the earthquake in wherever has on the, price of a, smartwatch 6 months later or something. At some level, we can just think about that in terms of a graph, because the fact is the connectivity, there's probably limited enough connectivity that if we just, had the nodes in a graph, we'd say, okay, there's either a path in the graph, great, there's a path in the graph. Now let's understand what was actually on those edges and so on. Yeah, I mean, the case that is the sort of the quintessential SPARQL case is asking these questions where you are constraining which edge you go down. Am I making sense? In other words, it's not, it's, there's a set of problems where basically the very existence of any edge is already interesting because there are fairly few edges. But, let's imagine that we are, let's do the bibliographic case, okay? The person who, I mean, again, it's a question of what is the query that we're trying to, I mean, a question would be,
I mean, one thing that you get from when you model sort of systems and machines, that transition edge, it's some action.
Yes. So what?
So then, a question that you often want to answer this, give me the set of reachable states.
Yeah, right.
Okay.
Which is not a SPARQL question. It's not a SPARQL style question.
Right. And you want basically all the possible endpoints. Given that you start over here, what are the things I can read?
Yeah, right. Can the airplane land without its undercarriage down or whatever?
Something like that. Or given these 2 points, can I get from here to there? Which is, you can formulate in graphs too, but it's
yes, but I mean, but those are questions that look, the case that is more like the SPARQL, the quintessential SPARQL case, you're really using the labels of the edges because you're asking a question that is, the author, who collaborated with somebody, who was the student of, who was the whatever, who came from such and such a country which was the descendant of such and such of the Ottoman Empire, which was the blah 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 blah.
But what your example just showed, they were not just all labeled edges. Some of them were actually nodes.
I see what you're saying.
So it's a mixture. Both really matter. Sometimes you want to go a certain edge, but sometimes you also want to go through a certain node.
Right. But so in the case of Wolfram Alpha queries, we have profoundly not found these kinds of things useful or an issue. Is that a fair statement?
I would say we haven't found them common.
Yes.
I think they are useful, but they're just not common.
Well, I mean, but we have, we are currently able to support queries. I mean, there's a trade-off, right? Because expressing the thing in natural languages can be quite kind of funky. I mean, I am quite confused because these cases, weren't there some SPARQL use cases in like the aren't there some medical SPARQL use cases like aren't these things like the
Yes.
mesh?
Yeah, for instance, an example I worked on some time ago was redoing some experiments about drug repurposing. They were looking at different path types that exists between different types of nodes like genes and tissues and expression and so on. And then they were training a neural net to figure out which path types are indicative of a certain chemical being useful to treat a certain illness.
Okay.
And then they were able to predict certain new candidates that were later found to be. Yeah.
But realistically, this is not a triple store story. I mean, something like, okay, so I'm going to give two examples. So something like that case of, genes, tissues, SNPs, whatever else. Those are a small number of types of thing, and they are very structured. That is, genes are expressed in certain tissues.
So in this
but I can see, like, think of it's almost like the author case, but like a music database. Here's the song. Who's the artist? What else has this artist done?
Yeah, but that's a trivial thing for us to answer without triple storing anything. I mean, that's a trivial relational kind of question, isn't it? Well, okay, the case that I'm remembering.
So the whole point about the drug repurposing example was that it integrated a lot of databases, like 25 or 30 different databases. And they investigated something like 1,000 path types, which had many more instances.
Yeah, I understand. So another case that might work that way is an anatomy database, because there are a few thousand structures, maybe 4,000 or 5,000 structures, but their relations are kind of random and complicated. Or am I, like this bone is connected to this joint, which has this tendon, and I can imagine a case where that would be, where it will be relevant to ask one of these sort of SPARQL-like questions.
Isn't it pretty, like ligaments and tendons, don't they all have just insertion points? And, they have 2 insertion points, all of them, pretty much.
Yes, but doesn't that define? I mean, I'm trying to think about the question. Yes. Okay.
So you take 2 different anatomical structures and say, how do they interact with each other?
Yeah, fair enough.
Because they might not directly interact with each other. Your left calf with your liver.
Right. But again, okay. All right. So let's again zoom out. Why are we doing? I mean, what are we going to use SPARQL for? We've got entity stores, and one possibility is that entity stores. Okay. So entity stores, one representation is relational databases. The claim is there are certain kinds of entity stores that are not well represented by relational databases, and for which, if somebody throws us one of those entity stores, we are better off representing it as a, through a graph database or through SPARQL RDF triples than we are representing it as a relational database. Is that a fair statement? I don't quite know what the characterization of that thing is.
So personally, I think we don't have to say that it doesn't fit into relational schema, so that's why we use the graph schema. I think it's a very nice way to store data, and I personally find writing SPARQL queries really easy. And I found myself fixing data in Wikidata just by writing directly SPARQL queries and then post-processing it in the Wolfram language. That was really convenient. So I see it as a nice query language and a nice format to store the data, independent of whether it fits into relational databases or not.
To store what kind of data?
Any kind of data. So because whenever you have some information you want to store, you can always put it in the one or the other, and there might be no strong argument, but there might be arguments like convenience or preference.
So where is SPARQL winning, so to speak? Where is it popular?
I think it's in various complex business process type things, in various government type situations, but I've not seen, I don't think it's a huge growth area right now.
But where was it born? I thought it was sort of born from
semantic web and those kinds of things. RDF was a creature of the semantic web, I think, in many ways. And I think
yes. And the idea is that every resource, that means the things that appear in the subject, predicate, or object position, are IRIs. That means if different people publish their data set and reuse the same IRI, that means you automatically know it's the same resource.
Yeah, it's a lovely idea.
Linking data, integrating different data sets.
And it's what Tim Berners-Lee thought was going to be sort of the follow-on to the web, but it hasn't really happened.
Yeah. So more and more vocabularies are being published. For instance, just recently, the time ontology has been published, and I found it useful to reuse in just the examples in this notebook, the time ontology, once or twice.
Time as in Time magazine?
In the sense of before, after, duration, and so on.
Oh, completely different. But so I don't understand that. I mean, that's the type of thing where we are, building support for temporal logic and all those kinds of things, which is not just an ontology. It's got more, it's not, to call it an ontology is kind of silly, I think. Yes,
so the idea is with our built-in functionality for dates and times, when we import such a data set, we automatically know what they mean in the data if they reused, for instance, the time ontology.
No, but wait a second. The time ontology is not going to handle things like it happens every Tuesday after, every first Tuesday of the month. That's not going to be the type of thing that's in the time ontology, is it?
I'll have to check that. I don't know it.
I'm sure it's not. I'm sure it's not. I'm sure it's a simplified version. I mean, what we've discovered in trying to implement a bunch of these time-related things and time granularity and time inclusion and time intervals and repeating events and so on, it's pretty complicated. And it is one of these things that, like so many other things we deal with, you can think of as an algorithmic set of relations, not a purely sort of static ontological set of relations.
Well, quickly looking at ontology, it seems to be able to represent repeating events and so on.
But it shouldn't be thought of as an ontology. It needs to be an algorithm. I mean, it's what's it going to do?
That's a little bit philosophical.
Okay, there are two things to consider. One is just making a statement when things are happening or in which order. Yes. And the other thing is reasoning about these statements. The ontology is just for stating the things. While
so will this eventually happen
Well, or no. Look, if things happen the first Tuesday of every month, how many of them will happen before Easter? Good luck. Because
Yes,
Easter is a
so-
computation. Go ahead.
So the time ontology, I don't want to say too much because I don't know it that well, but it's built on OWL, and the plan is to extend SPARQL to support OWL ontologies. That means we will be able to do some reasoning about it, but this is still in the future.
Yeah, look, I think that this idea is, it's funny. I happen to be writing a proto blog post about things to do with foundations of logic. And this seems to me yet another one of these cases where people, yes, logic was a good idea starting with Aristotle and so on, but is it really the way? I mean, this is one of these, let's represent the world using, these specific models of ontology. And I don't know. Anyway, we can yak on philosophically about it, but that's probably not what we should do. And we're late anyway right now. Okay, so what is the practical direction we're going to go with all of this stuff? I mean, it seems like what you're doing right now, Tony, is to build essentially a semi-independent package that can handle, SPARQL connections, RDF, things like that. Very much tied into the vernacular of SPARQL and RDF. So, and I think that's probably fine. And I think it's worth, go ahead.
Correct. This is definitely number one. Kind of have a representation of this that we can go to the outside world and connect also. And then I feel like step 2 is use this one as a first version to query entity stores with queries that we currently don't form. I cannot even form. And of course, also answering this. And then once we have some experience with this and see what we really want, then we can probably think on which part of the SPARQL, graph store, backtick, SPARQL world do we really need to query entity stores in general?
Okay, so fine. But so then what we would do is maybe we should package some of these public SPARQL endpoints as service connections, just so that we have a way to introduce them and document them in the system. I mean, in other words,
that would be a very shallow wrapper because it's just a URL.
I see.
But it would be maybe still not bad having kind of like something that is a URL but have a SPARQL endpoint somehow wrapped around.
Well, but I mean, the point that Tony is making, his stuff is going to be in some particular context. And I mean, the only point that I'm making is, so look, it sounds like your project, that what should happen is, we should package it up. It should be its own package, a SPARQL package, and that then we'll see whether people can use it with existing SPARQL resources. And then what Michael was saying is the next question of how this sort of finds its way into either our graph theory stuff and or our entity store stuff seems still a bit uncertain. Is that a fair statement?
Yes.
So I feel like it's relatively clear, no?
Okay, well, explain it.
Okay. Take one of our bigger entity stores and ask a question like, how do you come from point A to B? We couldn't form this query right now.
Okay, fair enough. But that requires language design for how to specify that query.
Yes, but what I'm saying, with the SPARQL one, we could already form it right now.
Yes, but in this SPARQL-esque...
That's what I'm saying. And then we have to think, what is our version of it?
Okay,
but we have a working implementation already.
Okay, so then what you're saying is, we could imagine a function that takes an entity store, maybe one that's in the data repository, maybe another one, and converts it into a SPARQL, into something represented in SPARQL with a local SPARQL server running, querying it. Is that what you're suggesting?
That's not even necessary. The idea is that you register an entity store like any other entity store, and you apply this SPARQL query to it, at least in the first step. If we later have more Wolfram language like function, then we can apply it to the entities too. But the idea is that we can apply directly a SPARQL select to an entity
But the entity store is stored how? Is it stored as SPARQL, or is it stored in the usual way?
It doesn't matter. So the idea is that you can have an in-memory entity store and the queries are appropriately translated, or you have an RDF-backed entity store, and then there's not much.
I know, but how would you get an RDF-backed entity store?
There are two approaches that we are considering right now. One is from the database people, having a second argument of entity store in which you define the backend, or having an RDF entity store. So either a symbol or something like this.
Where did it come from? Did it come because it was presented to you, from the beginning of time that way, from the outside world? Or did it come because you constructed, let's imagine I made an entity store that represented some mathematical thing where I just constructed every piece myself. Does it end up being RDF represented, or does it end up being the way we're representing an entity store right now?
Well, that wouldn't change. So you would probably just get a typical entity store.
Okay,
because
fine.
If you're constructing the entities manually, there's no need to convert it into RDF. The use case
but what you're saying is that the only way to get an RDF entity store is to already have an RDF entity store in some sense.
Yes.
Okay, but so then the question is, where did the RDF, it's like the turtles all the way down question, especially with this representation called turtle, but where did the original RDF entity store come from? In other words, what we've determined is that there aren't that many public SPARQL endpoints, etc. And we're also concerned, like within our company, I don't believe we have any RDF, any naturally occurring RDF, collections, triple stores. We have plenty of, we have some graph databases. We have plenty of many ordinary relational databases. We have many things that are just tables of various kinds. But I don't think we have any naturally occurring triple stores. Except maybe the few things we have in graph databases. But so my question is, where are people going to get their triple stores from?
I still think that's not quite the right question. The right question is take existing entity stores and ask complicated questions on it.
Okay, but that then requires that we convert them to triple stores to be able to ask those questions.
No.
Okay. So I'm confused somehow. So with the existing internal representation of entity stores, you can somehow run the SPARQL magic and...
Yes. So in the worst case, the entity stores converted on the fly into an RDF graph.
All right, okay.
But in various important cases, we can translate it into more efficient entity queries. That means we don't have to materialize the graph, and we just keep it as an entity store.
All right, so you're saying, so one thing we should do then is write down in terms of entity function, all these kinds of things. There's certain kinds of queries that the relational, backend can handle, and for which we have invented things like entity function because those are convenient for asking relational type questions. So similarly, there is presumably, and that's what we started looking at with graph cases and so on, there is presumably, the question is, if we're just going to query entity stores, we're not trying to make this general for graphs. If we're just trying to query entity stores with these paths, for example, is there a convenient Wolfram language representation of a path query in an entity store? Is that the right question to be asking?
Maybe because very similar things really come up with the molecule, we should be slightly more general. It shouldn't be maybe as general as the forward graph thing, but slightly more general than this. Because we want to see in a molecule, is there a certain chain of atoms?
Yeah, I understand. So you're suggesting, so why don't we try to, have you already addressed this question, Tony? Or to make a language level design for something that corresponds to a path in the triple store?
Yes, I have some idea that would be a property path pattern or something like that. But that would be for something like graph cases. To have something for an entity, no. There is an idea, something like an entity property path or sequence, but we haven't sorted that out yet.
Actually, we have a number of interesting comments on our live stream here. Let me just go through these, and we've got to wrap this up soon. Okay, so graph edge seems neat. I was once trying to make a graph for the interstate system and was hoping to give edge lengths like I-94. That's interesting. I mean, don't we have a way of weighting the edges of a graph right now, Roger?
Sorry.
Don't we have a way of giving weights?
Sorry, I thought I was muted.
Right.
Yes, we do.
Okay, so SPARQL seems very much to be find this subgraph in this giant horrible graph. Yeah, to some extent. Okay, somebody a resource with SPARQL query examples somebody is giving us. Let's take a look at what they sent. Discovered asteroids by countries. Yeah, okay, fine. I mean, again, that's not deeply tripleistic. That's just a one-shot thing, I think. Kind of a disappointing collection of languages there. What is this place? What is this anyway? Open data sets in Paris. Okay. Yeah, entities could become a giant triple store. Yes, we know this. Yeah, somebody is pointing out the entity system in Wolfram Language is more graph shaped than relational database shaped, for sure. And even our data sets obviously are deep and hierarchical in a way that relational databases are not naturally.
Actually, I wouldn't be so sure that the entities as they exist are more towards graphs. I would say.
I think that what I mean is the set of all of them.
Yes.
Because I think they're also very naturally relational as well.
Okay, so somebody's pointing out triple store is the best way to add structure to messily structured data. Yeah, kind of. I mean, you know, if you get stuff from natural language or something, you can make them up. I just have not seen. Somebody says here, I did a case study against that ungated data Microsoft let loose. Not quite sure what that means. OWL allows you to combine vocabularies, yes, to create one meta-ontology. Let's see, do entity stores have unique, so somebody is asking, do entity stores have unique persistent IDs for their names, properties, values? If so, it'd be trivial to construct URIs for the entity properties and trivial to create RDF from those URIs. Yes, the answer is yes, they have. I mean, it's somewhat complicated because there's, but yes, we have, our entities are intended to be unique permanent things. Well, with the footnote that if people start creating them, yeah, let's see.
You can locally have, 10 people can locally have the same entity and mean something different.
Yes, they can locally, but we have this mechanism for generating UUIDs, right? For our external reference mechanism generates UUIDs. We haven't, you know, we have certainly designed something along these lines where two people can generate entities that they locally both refer to as, I don't know, a particular species of monkey or something. But we don't necessarily know whether those people really mean the same thing. But for them locally, they've got UUIDs. And then at some point in the future, somebody can come in and do the grand unification and say, your two monkey species are actually the same species. But that's obviously a separate step and a complicated step. If two sets of people have their own ontologies. Anyway, let's see.
So in this case, you can build a so-called link set, say this ID is the same as this ID, using, for instance, the OWL vocabulary same as.
Okay. All right. Listen, we got to wrap.
Yeah.
This has been interesting.
One final question.
Go ahead.
So, which context should it be? The last time you suggested graph store context.
Well, what do you think? Michael, what do you think? Given, or should it admit it's more sparkly?
I personally like it because we might in the future think about adding other graph languages, for instance, Gremlin or Gcore or whatever. And this could all be in the graph store context.
I would also prefer graph store for now.
Okay.
I mean, like the FEM or IP opt, we have them in their corresponding overall name.
Okay. All right. Sounds good. All right. We should look at this again. I feel like we have not fully resolved the strategy of what we're doing here. I mean, this was very useful for me in understanding more about how these different, ways to represent data fit together. But I feel like we're not. I mean, it sounds like we've got one definite thing, which is to introduce an entity world path, whatever you call it, property path pattern, whatever you're going to call it. Didn't we already have something of that type? Weren't we already talking about that? Don't we already have a property path thing that's used in the relational setup?
Yeah, we were discussing it, but we are still for the relational part. We still have to come to relations once again and start using that actually. So we were only discussing the name so far. But
okay, but I mean that particular thing would be a thing that would be kind of a front and center type feature in the case of triple stores, but not a but a thing that is relevant but not so highlighted in the relational case. Is that a fair statement?
I think not, because in the relational statement, it's also very, very relevant.
Okay, but it won't have patterns in the relational case, or will it?
No patterns.
Right. Although you could, in principle, make patterns. It would just be rather inefficient and silly.
Yeah, well, the problem is the patterns won't be able to query, for instance, the edges, so to speak, because the edges in relational world translate to, specific kind of names of the table, so to speak.
All right. Why doesn't Tony have a think about how that could be set up for the triple store representation of these graphs? And then let's discuss this again. Seem reasonable? And let's meanwhile get this graph store stuff actually implemented, documented, etc., so we can let people try and start using it.
Yes.
Yeah.
Okay. All right. Good stuff. Thanks a lot, guys.
Bye.
Okay.
Bye.
Bye-bye. Bye.